Log on, tune in, find out. Another good idea from Cambridge.
Maurice Wilkes led an extraordinary life and a very long one. He was born before the First World War and lived to see the full flowering of the internet. In his prime, which lasted about 50 years, he was in the vanguard of the computer revolution. One of Maurice's earliest memories was Armistice Day, November 1918, when he was about 5 years old. The picture of him on the left was taken at about the same time. He was born in Dudley, Staffordshire, the only son of an aspirational middle-class family. His mother was a typewriter, when that was an occupation and not a machine. She gave up her job on marriage, and Maurice's father was a clerk in the estate of the Earl of Dudley, which had extensive mining interests. Maurice's father was ambitious and very capable, and at a very young age he was promoted to cashier of the estate. I think today we would call him the chief financial officer. The family became quite prosperous in a middle-class way, and Maurice was educated at King Edward's School, Stourbridge. It would be an overstatement to say that all of Maurice's early life was but a preparation for the EDSAC. But when digital computers arrived in the 1940s, it's hard to imagine his life taking any other course. Like a million other boys, he had a Meccano construction set at an early age. He liked to call it an English boy's birthright. His family encouraged a scientific interest, which for him was mainly electrical, and he played with batteries and lamps and bells. Radio broadcasting started in 1922, and like many other boys, he began to build crystal sets. One was of an advanced design. He was rather proud of it. He used an Osram valve, and it cost an astronomical 12 shillings and sixpence. In the sixth form, he was introduced to amateur radio. He learned the Morse code and obtained a radio amateur's license. Maurice once remarked that he'd heard it said that the best way of learning about the sea and the science of navigation was messing about in boats. And he thought exactly the same was true of electronics and amateur radio. The Wilkes family was prospering, and they even owned an elderly Singer 10 motor car. Maurice's father decided that Cambridge University was the place for Maurice. But of course, the family had no experience of higher education or how to go about getting it. However, the headmaster of King Edward's School was a Cambridge man, and he'd been a mathematics undergraduate at St. John's College in the 1890s. So that settled things for Maurice for his undergraduate years and for the 75 years afterwards. Maurice began his new life at Cambridge as a Cambridge undergraduate in October 1931. He decided on the mathematics tripos because, in his own words, he was hungry for mathematics. However, for him, the physical sciences were never far beneath the surface. He became a member of the Wireless Society, and he shared the 1931 Adams Prize for an essay on the electron theory of metals, and his final year, he took a course on wireless waves. As an undergraduate, Maurice never ventured into a laboratory, which he regretted, though he never regretted his decision to study maths. Of course, he would never have been a mathematician of the first rank, and he knew it. His strengths were different. He was an all-rounder, with a talent for electronics and tinkering that bordered on genius. He called it having green fingers. He never saw his undergraduate degree as anything other than a stepping stone towards research in a higher degree. His foray into maths was over, and he wanted to study radio physics, and everything pointed to working in the Cavendish laboratory under the direction of J.A. Ratcliffe. Well, Maurice graduated in June 1934, and a month later he was installed in the Cavendish. He was assigned to a group that was making a study of the propagation of very long radio waves. And this involved him careering around in a motor car, towing a caravan full of portable electronic measuring equipment, taking readings in the field, and undertaking a mathematical analysis afterwards. In every way, he was in his element, and it gave him a lasting interest in the physics of the atmosphere. The wider possibilities of computing entered Maurice's life in his second year as a research student when he attended a lecture by the mathematical physicist Professor Douglas Hartree. A few years earlier, in 1930, Vannevar Bush at MIT had invented an analog computing machine for integrating differential equations. It was called a differential analyzer. And Hartree, who was a professor of applied mathematics at Manchester University, had built a model differential analyzer from Meccano, and it proved surprisingly useful. And a copy of that machine had been made at Cambridge University for John Leonard Jones, who was professor of theoretical chemistry. And this Meccano differential analyzer was demonstrated at Hartree's lecture. Well, it was the first that Maurice had heard of the machine, and he asked Leonard Jones if he might make use of it. Maurice found the differential analyzer irresistible. His research threw up lots of differential equations to integrate, and he was soon quite an expert. So much so that Leonard Jones invited him to take charge of the machine and provide technical assistance for users. Even better, there was a small salary, just as Maurice's DSIR research grant was coming to an end. Well, he leapt at the opportunity and never looked back. One thinks of the mathematization of science as being a post-war phenomenon, but the transition was well underway in the 1930s, and Leonard Jones was in the forefront. In 1937, he persuaded the university to establish a computing laboratory. It was called the Mathematical Laboratory, an unfortunate choice of name that was finally remedied in 1970. Incidentally, Leonard Jones was an outstanding administrator and educationist. He eventually became Sir John Leonard Jones and Vice-Chancellor of Keele University. Leonard Jones was appointed director of the Mathematical Laboratory, and Maurice became assistant director with the rank of university demonstrator. Maurice set to work with characteristic energy, installing a variety of calculating machines and making himself known to the small world of computing experts. The laboratory had a budget for a full-scale differential analyzer, and a copy of the machine that had been produced for Manchester University was ordered from Metropolitan Vickers. This necessitated Maurice making a trip to Manchester, where he met Douglas Hartree for the first time. Hartree collected Maurice from the railway station and put him up in his home, and it was the beginning of a lasting friendship. When Hartree moved to Cambridge after the war, he became a kind of godfather to the laboratory. However, before the differential analyzer could be completed, it was 1939 and Britain was at war. The facilities of the laboratory were taken over by the Ministry of Supply, and Maurice was enlisted in the scientific war effort. Given his background in radio research, it was inevitable that he would find himself in the thick of radar research, alongside many of his colleagues from the Cavendish. This gave him a background in pulse electronics and a network of contacts that would prove more than useful when it came to building the EDSAC after the war. In the last year of the war, radar was no longer the research priority it had been, and Maurice's mathematics and computing expertise were put to use in operational research. By spring 1945, the end of the war was in sight, and the mathematical laboratory at Cambridge was re-established. The Ministry of Supply was prized out of its wartime occupation, and Maurice became acting director with the rank of university lecturer in October 1945. He had two remits. First, to conduct research into computing machines and methods, and second, to provide a computing service for users. In May 1946, Maurice was visited by L.J. Comrie, Britain's most successful computing expert. He had founded the world's first for-profit computing agency in London and he had prospered during the war. Comrie was helping Maurice to re-equip the laboratory. On this occasion, he brought with him a copy of the EDVAC report. The EDVAC report had been written by John von Neumann on behalf of the computer group at the Moore School of Electrical Engineering, University of Pennsylvania. As Maurice recalled, there were no photocopiers in those days, so he stayed up late into the night reading it. The EDVAC report described the logical design of the stored program computer, and Maurice decided that the laboratory had to have one. A few weeks later, Maurice received a telegram from the Moore School. They were planning a summer school in computer design, and would he like to attend? 1946 was not a good time for travel, and because of bureaucratic and shipping delays, he only arrived in time for the last 2 weeks of the 8-week course. Though it didn't matter very much because most of the course had been background material on numerical methods and electronics, in which Maurice was already well versed. And the Moore School was not free from red tape either. At the time the summer school started, the EDVAC was still classified, and they did not get security restrictions lifted until the final days of the course. The students were finally shown the block diagrams of the EDSAC projected in a darkened room. The picture on the left there shows one of the diagrams of the EDVAC that Maurice would have seen. Because of security restrictions, they were not allowed to take away any materials except their personal notes. But seemingly it was all that Maurice needed. Returning to the UK on the Queen Mary, he began to map out the design of the EDSAC. The name EDSAC was chosen to echo the EDVAC, so that there should be no doubt about the provenance of the machine. At all times, Maurice was more interested in getting a machine up and running quickly rather than having one of the highest technological performance. So, for example, he offered for a half megacycle pulse rate. If he had been a bit more adventurous, he could have built a machine that was twice as fast. But he reasoned that since the computer would be 1,000 times faster than anything previously available, users would be well enough pleased and would be glad to have the machine sooner rather than later. The key technical problem facing all the early computer groups was designing a memory system that could store at least 1,000 numbers and instructions. No one anywhere had built such a device. The Moore School advocated using mercury delay lines, which were a byproduct of radar research, so that's what Maurice decided to do. In October 1946, he had a great stroke of luck when he encountered a newly arrived Cavendish research student by the name of Tommy Gold. Gold was something of a maverick. He went on to become a distinguished astrophysicist and a fellow of the Royal Society. In the last year of the war, Gold had worked on a mercury delay line memory, moving target indicator device for the Admiralty's radar research program. And he was able to give the constructional dimensions to Maurice, and Maurice followed them to the letter. Before he could start construction, Maurice needed to build up an engineering team. Tommy Gold again came to the rescue when he recommended a seasoned electronics engineer he had worked with at the Admiralty's signals establishment. This was Bill Rennick, and he and Maurice shared the engineering work until EDSAC was complete. By the end of 1947, more technical staff had been recruited, and construction went full steam ahead. Maurice would have hated the description, but he was a multitasker. While Rennick and the engineering staff got on with building the EDSAC, Maurice had to attend to the post-war reconstruction of the laboratory. There was an academic program to develop and a computing service to provide. In November 1947, he established the famous fortnightly colloquia, which was a focal point for all the computer groups then working in Britain. A course on numerical analysis was instituted, with Douglas Hartree giving the lectures. The first 3 research students were recruited: John Bennett, David Wheeler, and Stanley Gill. The Metropolitan Vickers differential analyzer finally arrived, and Ben Noble was brought in to take charge of it. He was followed by Tony Brooker in 1949. Somehow, Maurice found time to write a book. published in 1949. But it wasn't a book about computers. It was called Oscillations of the Earth's Atmosphere. So Maurice was as interested in using computers as he was in building them. In 1948, it wasn't foreseeable to Maurice or to anyone else that computing would become a science and that computers would take over the world. For Maurice, the computer was primarily a scientific instrument. It was rather like an electron microscope or a radio telescope. It would advance research in his particular science, the physics of the atmosphere, and he wasn't letting go of it. And he continued to be active in that field right up to the end of the 1950s, when computers clearly were the future. The EDSAC sprang to life on Friday the 6th of May 1949, and 6 weeks later there was an inaugural conference which was attended by practically the whole of the British and European computing community. There were 144 delegates. After the conference, Maurice put his user's hat on and wrote his first real application program. It was for the integration of Airy's differential equation, a type of equation that tended to occur in atmospheric physics. In writing this program, he made one of the most profound discoveries in computing. That getting programs right was very difficult. His was a short program of about 125 instructions, and 20 of them were wrong. It was only after at least a dozen attempts that he finally coaxed the correct results out of it. Something needed to be done about the programming problem. And Wilkes handed the task of making programming easier to his research student, David Wheeler. Maurice was bowled over by the system that Wheeler devised. He called it a tour de force. They complemented one another rather well. Wheeler created a library of subroutines, each of which was a little masterpiece that almost had the quality of a mathematical theorem. This Maurice could never have done. On the other hand, Maurice brought into being a practical computing service, which would never have interested David. In 1951, the EDSAC programming system was described in a book, The Preparation of Programs for an Electronic Digital Computer, usually called Wilkes, Wheeler and Gill. And it was the first textbook on programming, and it was perhaps the single most important outcome of the EDSAC. The EDSAC was important for many reasons, of course. Not least, it provided a computing service that led to major scientific breakthroughs and leading to a Nobel Prize. It was the prototype of the Leo computer, which was the foundation of business computing in Britain. The summer schools in programming, instituted in 1953, brought scores of people into the field, many of whom went on to establish the first institutions of academic and industrial computing. But Wilkes, Wheeler and Gill helped shape programming practice worldwide. It is a book that a modern-day computer scientist might choose for company when stranded on a desert island. He would have time to marvel at the programming miracle achieved with less computer power than the proverbial digital watch.